Hello colleagues, and welcome to week 2, unit 8 of SAP Cloud Platform Version Control with Git. In this session, we will talk about troubleshooting tricky Git situations. I'll also describe a typical Git problem that someone on your team might need to solve. Then you'll hit pause on the video and take the time to solve it. Finally, we'll walk through the answer. The sort of problem scenario we are solving in this lecture will be the kind of problem you will see on the final exam and on some of the weekly assignments as well. If someone comes to you with a Git question, the first step is to ask, what are you trying to do? This may sound obvious, but I've discovered that people often have to stop and think about the answer. The second step is to ask, what is the current state of your repository? The Git history pane will answer this question for you, but I find it helps to sketch out the state of the repository on a scrap of paper as well. Next, you ask, what is the target state of your repository? Once you know what they're trying to do and what the repository looks like right now, you use that to figure out what the repository should look like when they're done. It helps a lot to sketch out this step on paper as well. Now, once you've drawn out what the repository looks like now and what you want it to look like, you can use the repository management tools you've been learning this week, merging, rebasing, resetting, to move your repository from where it is now to where your colleague wants it to be. One additional thing I've learned is that a mixed reset is very often a part of the best solution. I sometimes joke with colleagues who bring me Git problems by saying, mixed reset is the answer, before they even tell me the problem. That doesn't mean that you can just jump in and use a mixed reset. You might have to start by creating a new branch or using some other kind of tool. But being skilled at using mixed resets can really come in handy. So here's a real-world problem for us to think through and troubleshoot together. Your colleague has been working on a prototype branch for 3 weeks, and after dozens of commits, he wants to integrate into the project's master branch. But he's frustrated because he doesn't want all his dozens of commits to be in the project record, since most represent failed experiments. Now, what is the first thing you should do to help? The first thing you should do is ask, what are you trying to do? He says, well, I'm trying to simplify my experimental branch so it doesn't have so many commits that aren't valuable to the project history, and after that I want to incorporate my work back into the master branch. What next? You now ask, what's the current state of your repository? Then you sit down with him and use the Git history tab to figure it out. Once you draw it out, it looks like this. You have many commits on the master branch and a couple dozen commits on the experiment branch. So what do you do next? You ask the question, what's the target state of your repository? After discussing with your colleague, you figure out that he wants his repository to look like the picture in this slide. He wishes that all his commits in his experiment branch were just boiled down to a single commit. But eventually your colleague really wants things to look like this slide. He wants his work to be moved to the master branch. So this slide depicts your problem statement. How would you get there? Which of the Git tools we've worked with so far could you use to get from the left picture to the picture on the right? Of course, there's more than one way to solve the problem. Now, with the number of participants in our course, it seems very likely to me that some of you are going to come up with a better solution than the best one I could come up with. And once you've seen my best solution, if you think you can top it, I really encourage you to post your solution to the course forum. We will all learn. Now, I invite you to pause the video and take as long as you need to write down how you would solve this problem. Figuring out how to solve problems like this one can take some time at first, but once you've taken the time to solve 2 or 3 problems like this, the solution will start coming to you much more quickly. So for this one, I'd recommend taking as long as you need to figure out what you think the best solution would be. Ready? If so, go ahead and hit pause now to figure out the solution. Okay, you've hit pause. Welcome back. At this point, you've taken a few minutes to work out the problem on your own with a piece of paper. Personally, I could think of 3 separate solutions to this problem. One of them seemed clearly superior to the other 2, and I'll go over that solution last. First, you could rebase directly from the experiment branch directly to the master branch. If you have conflicts on all 24 commits, you could hit skip patch 23 times and then perform the conflict resolution in one final step. Let's go and draw this out. So I went ahead and pre-drew the problem statement, as I'm sure you did as well. And if we do a rebase, then essentially we're going to rebase this experiment branch onto the master branch. Now, if we do that, if we're lucky, and we have, now I just drew 4 commits here, but you can imagine 24 commits, and you can imagine 20 commits here. It doesn't really matter how many commits, it's the same sort of scenario. So if you hit rebase and you got lucky and you got a bunch of conflicts, then you could hit skip patch for 23 times and you would end up with this. So experiment would point there. Let me just, experiment would point here. There we go. But there's a problem. First of all, you would have to get 23 conflicts in order to do that. Even if you do get 23 conflicts, you're going to hit a lot of manual work because you're going to have to make sure and hit skip patch the exact right number of times, figure out which commit you're resolving at that point in time. But more importantly, it's very unlikely that you're going to hit 23 conflicts. Most likely what you're going to do is, if you don't get any conflicts, or maybe just 1 or 2, then you're going to just redraw the entire branch onto here, which is not what your colleague wanted at all. So the main problem with that solution is it doesn't work all the time, and even when it does work, it's pretty complex. Okay, so that is one solution. Here is another solution. Another solution is to check out your experimental branch and perform a mixed reset directly onto master. So going back to the drawing, if we were to do that, then essentially we'd be performing a mixed reset, and so we would be moving experiment here, and you would have a bunch of stuff, all these commits would essentially be moved to your working area, and you could do, and then you could figure out manually which of the changes in your working area you wanted to complete. And after you figured out manually all the changes in your working area you wanted to complete, then experiment would point here. Now there's one giant problem with this, and it's actually an enormous problem. And the problem with this is, when you do the mixed reset, what's in your working area will not only comprise all this work, it will also undo all of this work. Remember, we said these were 20 important commits. So you'll be sitting in your working area, and you're going to have to go and examine each and every one of these commits and figure out what work was done there and redo that work in your working area. That's going to be incredibly tedious and time-consuming and error-prone, and it's almost certain that you're going to make a mistake, at least one mistake, if not several. Even if you get it right, it's going to take forever to get it, and it's because it's going to be so complex. So that is actually a much more complicated solution than we would like. So is there a simpler way to do it? Is there a way to get Git to handle all the complexity for us? Here is the best solution I could think of. You start by collapsing the entire branch into a single commit by creating a new branch and using a mixed reset, and only then rebase your single commit onto master. Let's go to the drawing and draw this out. So what I'm suggesting is that you do this. You create a new branch here on this commit, temp, say, temp branch. And after you create that, you perform a mixed reset from experiment onto temp. When you do that, you'll have collapsed all of this work into your working area, your staging area. If you stage it and commit it, you will then have experiment pointing to here. So that's step 1. Step 2 is, and I'll change pen color to purple for step 2. Step 2 is you rebase from temp onto master. I'm sorry, you rebase from experiment onto master. At this point, you only have one commit to rebase. So after performing let's redraw this. Now, and I'll skip the temp branch because we can delete that as soon as we're done with it. you have this. Master. After your first mixed reset, an experiment goes here. So now you take a rebase and you rebase from here to here, which will take this one commit and boop, drop it on there, getting rid of this. Okay, there are several advantages to this solution. First of all, when you perform this initial mixed reset, you're not going to have to do any analysis. All you're going to do is take what's in your working area and commit it, and stage it all and commit it. And that will collapse all of this work here. You won't undo any of these commits because you only brought it back in time to this temp branch. Your staging area will only contain this work. So all that complexity was handled. The even bigger advantage is that once you do the rebase, you will get at most one conflict, and that conflict will be very easy to solve. All you have to do is say, well, which of these two things do I prefer, or how do I incorporate them together? So this is about a 2-minute solution versus the very, very complex solutions we saw earlier. Okay, so Git has performed all the complex analysis for you in that solution. At this point, you have an idea how to bring together all the tools we've learned to solve a complex, real-world problem. In the real world, the problems you encounter might be more complex than this one, but the framework for solving the problems can be the same, and the solutions can be just as elegant and easy to implement. Remember to start by asking the same 4 questions, and remember that mixed resets are frequently useful in solving Web IDE Git problem scenarios. Now, if that was a little confusing, rewind the video, watch it again, and I would encourage you to even experiment with doing this in the Web IDE so you see what I'm talking about. In the first version, I demoed it, but it took a little bit too long, so I just drew it out and left the demo as an exercise for you if you choose to do so. In the next unit, we'll learn about one last tool that's both simple and easy to illustrate, cherry picking.